Okay, the final lesson in this chapter is going to be the area and volumes of similar figures. And here we're talking about three-dimensional solids versus the two-dimensional figures we talked about in the last lesson. So we want you to learn to find relationships between ratios of areas and volumes of similar solids. So first let's define what a similar solid is. Similar solids have the same shape, which means that all their corresponding angles are congruent. And similar solids are also proportional, which means all their corresponding sides are proportional and they'll all have that same similarity ratio. So we need to identify similar solids. Let me set this problem up for you. Okay, so when we're identifying similar solids, we need to check that the similarity ratio is the same for all the corresponding sides in all three dimensions. Now, if we're dealing with circular objects like cylinders that we have here, we don't need to check length, width, and height. We just need to check radius, which covers the two-dimensional circle, and then the height, which is our 7 centimeters here. So 7 times what number is 21? Well, that's 3. And 3 times what number is 9? Well, that's 3 as well. So since our similarity ratio is 3 for both of those dimensions, my two cylinders are considered to be similar. So let's talk about areas and volumes of similar solids. So if we are given two similar solids and they have a similarity ratio of A over B, or we might even put it side by side, A to B, then the ratio of their corresponding surface areas is going to be the same as the ratio of corresponding areas for two-dimensional figures. Because remember, surface areas are talking about just 2 dimensions, even though, like if we're talking about a cylinder, we've got that circumference times the height as that a round dimension. So the ratio of their corresponding surface areas is that similarity ratio squared. And the ratio of their volumes will be that similarity ratio cubed. Okay? And the way to remember this is that if we're talking area, our dimensions are something squared. If we're talking volume, our dimensions are something cubed. And so that's how to remember the similarity ratio differences between surface area and volume. So here we have an example. Given two similar solids whose volumes are 125 centimeters cubed and 27 centimeters cubed, find the similarity ratio between the figures, and then find the similarity ratio between the surface areas of the figures. So if we're looking at 125 divided by 27, right, that's going to be equal to some similarity ratio A over B cubed. So if I take the cubed root of 125, I get 5. If I take the cubed root of 27, I get 3. So my similarity ratio is 5/3. And that's a similarity ratio between the figures, okay? And so each individual dimension of those figures will have a ratio of 5/3, okay? And that's, remember, because this is greater than 1, we're talking going from smaller to larger. If we were talking going larger to smaller, it would be 3/5, the reciprocal. Now the similarity ratio between the surface areas of the figures would be 5/3 squared, which would be 25/9. Okay? So that's for the surface areas, and this is the similarity ratio between the figures themselves. And then the volumes have a similarity ratio of that, which is 5/3 cubed. So here's a different example. Given two similar solids with a similarity ratio of 2 to 5, with the smaller solid having a volume of 7 centimeters cubed, find the volume of the larger solid. So my similarity ratio is 2 to 5, right? So the smaller to the larger would have me multiplying by 5/2 cubed, right? So smaller solid, 7 centimeters cubed, times 5/2 cubed should equal the volume of the larger solid. So this will be 7 times 125/4. which will be 8/75, which does not reduce down. It's equal to 218.75. Okay, is the volume, of the larger solid. Okay, so pretty neat concept here. We can find missing figures by not knowing anything other than, so we don't know any dimensions, we don't know anything other than we have a volume, we have a similarity ratio, so we can find the other volume, not knowing anything else about the object. So this is kind of convenient to know. So what we've learned what similar solids are. We've learned that the ratio of surface areas of similar solids is a square of the similarity ratio between the two solids, and the ratio of the volumes of similar solids is a cube of the similarity ratio between the two solids. We've also seen a couple example problems on how to apply that. That's it for today.